Computers are pretty good about keeping track of time, but now and then they drift out of sync. The longer a system is up, the more opportunity tiny differences in how the system counts time pop up and compound. To fix this, systems periodically check in with a network of trusted servers, which receive accurate time information from atomic clocks to reset their own clocks. The protocol we use for this is called NTP, or Network Time Protocol. The network of servers that provide time information is called a pool. As science fiction-y as time pools and time servers sound, they perform a very real service for systems on a network. Many services require servers and peers to have accurate time, and it makes comparing events in log files a lot easier if all your systems are ticking along to the same clock. While you're usually fine relying on the NTP pool to set the time on machines on your network, you can set up your own time server and configure clients to synchronize with it rather than servers from the internet. What we'll do in this video is configure our router to run the Crony NTP daemon as a server. Then we'll open up the firewall to let the service through. And then we'll configure Crony on one of our client machines to point to our router for time information. Crony is already installed here on my CentOS machine, but you may need to install it with your system's package management tool. Let's check if it's available with the Crony C command. Yep, there it is. I'll quit. We'll take a look at the Crony C command in more detail later on. So here on the router, I'll edit the NTP configuration file. I'll write sudo vi etc crony.conf. Down here toward the bottom, I'll make sure that the clients on my network are allowed access with the allow directive. I'll write allow 192.168.0.0.24 and allow 10.0.2.0/24. Toward the top here, I can see the listing of the time servers that my router is going to connect to get time information. I don't need to change anything else right now, so I'll hit escape, :WQ to save and quit. So before we start up the service here on the system, I need to make sure that the older NTPD service isn't running. Depending on your distribution, that might be already active. So I'll write sudo systemctl status NTPD, and it looks like that's not loaded. Good. We should also check to see if Crony is already running. On my system, I know it is, but you can check with sudo systemctl status cronyd. There we go. So because it's running, it hasn't reloaded the configuration file that we just edited. So we need to restart the service if it's already running. So I'll write sudo systemctl restart cronyd. If it's not running on your system, you'll just want to write systemctl start cronyd. Okay. Now I need to allow access to the service through the firewall. So I'll write sudo firewall cmd, and this will be permanent in the public zone. And I'll write add service NTP. So the firewall will automatically figure out that we're trying to run NTP, and it'll open up UDP port 123. And I'll reload the firewall. Okay. Let's switch to the client system and set it up to use NTP. First, I'll open up the cronyconf file over on this system. I know it's already installed because this is a clone of my CentOS system that had it installed. Again, you may need to install Crony if it's not already installed on your system. So I'll open up the cronyconf file with sudo vi etc cronyconf. And here at the top of the list, where the servers are, I'll add our server with server 10.0.2.6, and I'll put the word prefer after it. That'll tell Crony to prefer this server over internet servers. But if something happens to our server, the system will fall back to using internet time servers. So I'll save this. The Crony software includes a client application called Crony C that lets you interact with the system and change and collect information. I can take a look here on my system at the servers that Crony is using with Crony C sources. The caret on the left represents that these are servers, and then the asterisk represents which one is being used. Right now, the asterisk on mine is next to gateway, which is the name that resolves for 10.0.2.6, our router, which is also our gateway. On your system, it may take a moment for this change to show up. The other 4 servers listed here are part of the NTP pool. They'll be different on your computer. The stratum column here tells us how far away from the true time sources each server is. Stratum 0 is the atomic clocks that are the source of truth. And then for every level further away, the stratum increases. I can see what specific information we're getting with Crony C tracking. And here I can see how far off of NTP time the system is. So it's great that we have this time information, but we need to take one more step to make sure our system synchronizes its time with the Crony service. The command we'll use to control how the system's date and time gets set is called timeDateCTL. This being the time and date controls, we can set the time and date to anything we want. Let's temporarily set it to midnight, just so we can watch NTP sync it back. I'll write timeDateCTL set time 00:00. And let's check it out again. timeDateCTL. There we go. Local time is set to midnight Pacific Daylight Time. And now let's change this here that says NTP enabled no. I want to set my system to sync with the NTP server, so I'll write timeDate CTL set-NTP 1. And now if I run timeDateCTL again, I can see that not only has the time synchronized back, that's the current time, but it's also changed over here to NTP enabled yes, and it's now picked up that we're synchronized with NTP. As with everything we've seen so far, there's a lot more options you can configure for your particular environment. But we've seen the basics, and that should give you a jumping off point for exploring even more.